how many of you guys have done web development before 6148?
Or 6148.
Okay. How many people have done programming before 6148? Okay, pretty good. Yeah, so basically, GraphQL is a thing people use to do data loading in their app. And as far as I understand, and I guess I'll have a whole slide to ask you guys more questions about what you're working on. You guys have had some kind of curriculum so far in the class where you've learned to make, web apps. I've heard you use Node, use maybe Express for a web server, use some templates on the server side. So I think the first thing I'm going to have to go through is to give you guys a little bit of a history of web development. But first, back in my day, so one of the things I want to brag about is I actually did do 6148, which used to be called 6470. Back when I did it, I did it twice, and it was a really good time, so I'm really excited that you guys get to participate in it. I think both for myself and for some of my coworkers in Meteor, this class was the first time any of us did web development, and now we work at a company that makes tools for web development, so I can say we got pretty excited about that. So yeah, I'm really excited to be able to come back here and give a talk, sponsor the class, and hang out with you guys. So again, how many of you guys are using Node for your project? Raise your hand. Leopard print jacket. Are you using something else other than Node for your project?
Oh, we're using Node. Sorry.
Oh, okay. Sorry, no, I don't want to put anybody in the spot like that anymore. How many people are using something other than handlebars to render your HTML? Or is everyone using handlebars? What are you using?
Spacebars.
You're using Meteor. How many people are using Meteor? Okay. 3 or 4 people. Great. So, one of the things that's pretty different about Meteor, for example, than from maybe what a lot of other people are doing in the class, is how the page is actually displayed. When the person goes to the UI, what happens in the browser that causes them to actually see an app there. And so this is where the history of web apps comes in. So, back in the day, like in 2010, which is apparently decades ago in web development time, almost every single app was built by using some kind of a web server to display HTML, and then that HTML would be sent to a web browser, and the web browser would display it much like you would display a document, right? So HTML was kind of like the document format of the web. And you guys might have heard of these frameworks like Ruby on Rails. You might have heard of PHP. That was a pretty popular one. Django. Those were some really popular ways of making apps like this, for which you guys are currently using Node. However, there were a lot of downsides to that approach, namely that every time you do something in your application, you have to essentially reload the entire page. And so, when you click on some sort of button or you submit a form, that goes back to the server, that regenerates an entire new page of HTML using some kind of server-side template maybe, and then that gets displayed to the browser after the server's had a chance to deal with it. However, I think starting in about 2012, people started exploring a different approach to web development from that, which was to do all of the UI rendering on the client instead of the server. So instead of the server sending HTML to the client, the server would send a bunch of JavaScript code, which is pretty much the only language you can run in a web browser, so you kind of have to use it. Server would send a bunch of JavaScript code, and then that JavaScript code would later talk to the server and load only the data it needs. So all of your UI code would live in the browser already, and you would just load data as you need it. And that's what Meteor does. You don't really have to do a lot in Meteor to get that to happen. If you use Node and Express, for example, you would have to define API endpoints and stuff like that. And the benefits of this client-side rendering approach are if you have complex UI interactions, you don't have to do as many round trips to the server. You can easily create new UI on the client. I don't know if you guys have done a bit of jQuery, I think. Yes, okay. And what kind of stuff did you guys do with jQuery? Like, what was one thing? Are you guys using it in your apps today? Someone raise your hand if you're using jQuery in your app. Okay, nobody's using jQuery in your app. You. What are you doing with it in your app? I'm just curious.
When I don't want to use, like, normal JavaScript, I just use jQuery. It's like easier for me to process elements, and it's just an app
situation might you need to access elements in?
For like a key, for JavaScript, I would just use that element by ID, but to query it, just use a different one.
Right, I guess what I mean is like, there are particular use cases where you might want to do that. Like for example, you want to update some part of the page without reloading, right? You want to, like, somebody clicks a button, you want to like display a new element, or you want to remove an element or something, or like show a loading bar, or like whatever you're doing. And so the benefit of doing client-side rendering, which is where you basically, you write your entire application in JavaScript, all of your stuff is rendered that way. And what that means is you don't have to create exceptions where you do something on the server and something on the client, because you can just do everything. So anyway, another great thing about this was that it was more similar to native mobile apps. So, you guys might have heard that mobile development is a big deal these days. Almost every company is rapidly trying to think about how they can create a mobile app, and people are more and more interacting with everything they do through mobile. So, you might have written a server-side rendered web app before, but as soon as you have to go to mobile, that's definitely not going to work anymore, because you don't want to be sending HTML to your iOS or Android app. You want to be using the native UI elements that Android and iOS provide, and then just load that data from your server. So then another trend that's been pretty prevalent in larger companies is using something called microservices, which is the idea that once your app gets larger, you don't want to have just one backend, right? So you might write a backend in Node, and then later on you might want to add something that does machine learning, for example. And you probably don't want to write your machine learning code in Node. You probably want to use something that's more appropriate for that. Like maybe you have some machine learning library that you're using through Google Cloud with Java, or like maybe it's Python or something like that. So at that point, what often happens is people end up with multiple different applications on the back end that they're talking to. And so you might see kind of a problem here that a lot of people run into. By the way, this talk is not super relevant to your app in 6.148. If you read the description, it's about something that you're very, very likely to encounter as soon as you go work at a company. A lot of companies that you might get an internship or a job at are going to experience this kind of thing. So anyway, this is a situation a lot of people ran into, is they had all these different backend services, they had these different UIs and different platforms. And you can see there's a lot of different lines here, and so that's, every time there's a line, there's something that can go wrong. Like you can load data improperly, you have to go talk to a bunch of different teams, or like people who wrote those different parts. So what people did is they introduced an API gateway. So basically your UI still talks to one API, but on the back end, it's a variety of different backend services, like your machine learning service, your photos service, whatever it is. However, now you have another problem, which is now you have a bottleneck where every time you want to do anything anywhere, you have to add something to this API gateway. And so this is kind of the state that most people are in. They're either in this state or they're in the state from the slide before. Pretty much every company has multiple different UIs that are talking to their backends, and most companies have some multiple number of backends, and whether or not they have an API gateway, pretty much what it looks like. So, how many of you guys have heard of REST APIs? Have you guys used any REST APIs, like loaded data from some sort of external service? Raise your hand. One person? 2 people? Okay. So, basically, as you can see in this situation, you're running multiple servers. You might be loading data from some external database, and REST APIs are currently probably the most popular way to do that. It's something that you can Google like how to create a REST API in Node, and you'll get like 10 billion examples. And the way that REST APIs work, which is currently the main way that people use to load data into the front ends, is you usually have a URL, but that URL returns data instead of HTML. So you might have a URL that returns, let's say your to-do list app, which is everyone's favorite example. You might have a URL that returns data about a particular to-do list. You might have a URL that you can send a post request to create a new to-do list. You might want to update that to-do list. So in these types of APIs, a lot of things are represented in terms of different actions you can do on a resource, and that resource is represented by a particular URL. So looking at just the description of this API, the first question that might come to mind is like, what am I even going to get from the server when I send a request to this to-do list /5 endpoint? If I'm trying to write some kind of app on top of that data, like I have no idea what it's going to send me. So I have to go read some documentation, or I have to call it myself and figure out what it returns. And then another question here is, well, let's say you want to display some page in your application, it might not be enough to just know information about the to-do list, like what it's called or something like that. You probably also want to know something about the items in that to-do list. And so in this architecture, often you end up having to do multiple requests to get the data you need. You first have to ask for the to-do list, and then based on that, ask for some of the items. And especially on mobile devices, for example, you can end up with a lot of round trips to the server to get data that like you might have been able to get one visit. This is a fun slide, this is the GitHub API. So this is what you get when you ask for one repository in the GitHub API right now. So if you wanted to build an app on top of GitHub, and you wanted to get like the name of the repository and maybe like the author, this is what you would get back. I think it scrolls for a full minute. But the point here is you get way too much data back because they send you all the data they have, pretty much. So basically, as you can see, there's a tension between having fewer endpoints that return a lot of data, so that you don't have to do a lot of round trips, but you get 100 pages of stuff, or you have to make a lot of specific endpoints, but then it's not efficient to talk to the server. So that's pretty sad. So that's where GraphQL comes in. So basically, a lot of these companies have this type of problem where they have these types of APIs that return basically the same data every time. And GraphQL is the idea of an API that can return different data based on who's asking for it. So the server declares what types of data are available in a really fine-grained way, and then the client can specify what data it needs, and the server sends you all of that in one request, and we'll see what that looks like in a second. So these are three different things you might deal with if you're working with GraphQL. The thing on the left is a schema. How many of you guys have dealt with like database schemas before? Like had to design like some sort of SQL database. Sometimes they make you draw these little diagrams, those little arrows. Sometimes they have stars on one side. I don't really understand that stuff. But basically on the left, every GraphQL server comes with a schema. And so, let's say you are creating some sort of blog platform. You might have a thing in your schema that describes a blog post, or you might have a thing that describes an author. And this isn't the schema for your database, because your database could be anything. It could be some microservice, it could be SQL, it could be MongoDB, but this represents the schema for your API. And so now that you have a schema for your API, you can write a GraphQL query. So this thing in the middle, the GraphQL query, is kind of like the main thing in GraphQL. So like you saw with REST APIs, you just send a URL, which pretty much limits the amount of stuff you can describe. You can describe the URL, you can maybe pass like an ID or some parameters. As you can see, GraphQL is like a bit more complex, but also more powerful, because it lets you put in all of the fields that you need and also query nested data. So I'll show you guys a little bit in a demo later. But the most important part is that the result that you get back from the server exactly matches the request that you sent. So you want to get the first name and the last name of the author, but you don't want to get their home address. You won't get it because you didn't ask for it. And so basically what that means is the server doesn't have to worry about having a lot of data available. And at the same time, the client doesn't have to worry about getting data it doesn't need, and it can also get data without doing multiple requests. So this is kind of a visualization of how a GraphQL schema might map onto a query, right? So you can, I guess the projector is a bit bright, but you can kind of see that different parts of the query are highlighting, and that's different fields in the text you're fetching from the server. So like when you start out and you query the hero field, that returns a character type, and then that has a name. And then if you query the friends on that, you get a list of friends, etc. And then one last thing in terms of introduction is another really cool thing is just like a REST API. REST is not a particular implementation, right? You can write a REST API, because it's such a common technology, you can write it using Node, you can write it using Rails, you can write it using Go. Any language you can imagine, there's a way to write some kind of API with it. And the same is true with GraphQL today. So it came out about 1.5 years ago, and it was originally invented inside of Facebook and used inside there for about 4 years. And then they open sourced a specification, which is basically just a description of how an API should work to fit the GraphQL mold. And so you can basically get servers, clients, and developer tools for like any platform you can imagine, which is pretty sweet because most of them came from the community outside of Facebook. So yeah, basically before you had to think about what kind of API your consumers or your user interface needed, and then hard code the endpoints that satisfy those needs. But now you can just ask for the data you need, and the server will return it to you on the fly. This is my favorite metaphor right now, which is, if you think of current APIs you might be using as this really old-looking phone, it has a hard-coded interface, right? It has a dial, and the only thing you can do is input numbers one at a time, because that's what it was designed for. It was designed to put in phone numbers. But the best part about the iPhone was that it went all in on the touch screen, and it didn't have buttons, which meant that every app that you were using on that phone could have its own user interface that was designed specifically for that app's needs. And so I think if you look at REST APIs or a lot of other current API technologies as the phone on the left, GraphQL is kind of the one on the right, and I think it can really replace REST APIs in the next couple of years. And is rapidly doing so, and I'll show you some company logos to make that seem more true. So let's look at what it's like to work with GraphQL first. So this is what I showed you before, and let's look at what this is like in real life. So essentially when you're implementing GraphQL server, what you're doing is you're implementing this backend schema. So when you're implementing your REST API or you're writing a Meteor app, you kind of implement named endpoints. Both GraphQL, you implement a schema. Oh, spoiler alert. Okay. So let me just really quickly show you, just so we're not like doing slides the whole time. Okay. It's going to be pretty small text, so let me make this bigger. So this is the language that I was showing you guys before. Is this big enough for you guys to see? Anyone having trouble? Okay, perfect. So this is the language I was showing you guys before, which is the GraphQL schema language, which describes what kinds of things are available. So you can see this is a JavaScript file that I'm writing that I'm going to run with Node. So one thing I do is define the schema, but obviously this schema doesn't tell us where the data is coming from, right? It tells us what data we can expect to get, but it doesn't help us load it from a database or some sort of other API or anything like that. So we need a second part, which are called resolvers. So, for example, you have an author type in your schema, which is here, and that has a list of posts on it. And so the one thing you have to specify is, how do you get that list of posts for an author? So you go over here to your file with resolvers and you say, okay, for the author type, when you ask for the posts, return me the posts. So over here, instead of having a database, we just have an array of objects, basically. It's a pretty simple example. When you query this post field, just return the posts that belong to the ID. So, the coolest thing about GraphQL from this perspective is you can connect it to literally any backend or database, because the only thing you're doing is writing plain JavaScript code that can load the data in any way you want. So let's run this. So conveniently, I've already ran it to make sure it works. Otherwise, it'd be sad. And then we get this thing. So this is, I would say, GraphQL's not so secret weapon, which is, I guess for the people who have used REST APIs before, a big activity that you engage in when you use an API of that kind is reading documentation. And documentation really sucks. Like, first of all, everyone hates writing it. The fun part is building the API, not describing how it's supposed to work. And the second part is, it also sucks to read, because you can never really understand what the person wrote and what they were trying to tell you. So now that we've defined that schema in that file, we can use this tool called Graphical, which is really clever because they took the word GraphQL and they put an I in the middle. And so it's like a graphical editor. And then you can get auto-completion for your queries. So instead of going to read any documentation, like I'll show you now, you can go to any API that supports GraphQL, open this tool, and know exactly what data you're going to get. So you're like, okay, I want to get the list of posts. I guess posts have titles. Okay, great. Like I can query that. I guess I already did that before. Like let's say I want the ID. Great, now I have the ID. Let's say you want the authors. That's not the right key. I should use two hands. So you want the author, and on the author you want their first name, for example. So now you have the data based on the schema. It told you exactly what data was available in that API. You could type it really easily without reading any documentation. You got exactly the data you asked for. You didn't have to do multiple requests. Like sometimes you might have to ask for the post and then ask for the author separately. The other half of it is building the actual app. So I've been talking about this in the context of building applications that are rendered on the client. How many of you guys have heard of React? Have you guys used React by any chance, or just heard about it? Okay, that's good enough. So React is basically, I would say, one of the most popular technologies these days for building these kinds of client-side rendered apps. So, you write a language that looks somewhat similar to HTML, has some HTML-like elements, but all the code to display those HTML elements runs on the client instead of on the server. You can also run on the server, but the client is the default place. So, let's say we defined a React component. This is basically just React code that you would write to define the component. But then how do we load the data from our server into that component? And it's very simple. You just write a GraphQL query. The same way we wrote that query in that graphical editor thing, we can just drop that query into our code, use a library that allows us to attach it to our component, and then we have all the data we wanted. So again, you don't have to mess around with making requests, waiting for stuff, like doing multiple requests, anything like that. Everything is kind of handled for you. So if you guys are building client-side rendered apps in the future, you might look back on this and remember that this is easier than that is. So the last thing I want to show you in this little demo section, here's the actual app that we built. So, here we have the query that loads some posts in JSON form. Here's an app that has React components, has the same posts here, lets you upload them. So pretty simple. But this data is loaded with that query. So one of the companies I want to talk about was GitHub. So this is the GitHub Early Access Developer Portal. This is something you can easily go to if you just Google, I can just show you. If you Google GitHub GraphQL, you guys probably, I guess you have to use GitHub for this class, right? So you guys have all used GitHub, that's great. If you just click on the first result, it'll take you to this page where you can click on GraphQL Explorer. And you can log in as your GitHub user, and now you can use GraphQL to query your own data. So, for example, you can get yourself, I don't know why they called it repository owner, but again, I have not read a single bit of documentation for this API, like I have no idea what they did. But I can get my avatar URL. I can get a particular repository, for example. So it'll tell me what arguments I can pass. Okay, I'll get my repository. I don't remember what repositories I have. Okay, I'm gonna get all my repositories. And so they have this little, their schema is a little bit interesting, but with a little bit of work, you can get your repositories. Funny thing here is that I ran this query earlier before the talk, and it turns out that several of these are actually for the 6.6470 class. So I guess that was the first time we used GitHub, because that's the order they return stuff in. So so another thing to note is real companies like GitHub are considering using this technology for their public API. So it might be helpful to use that data. If you guys want to learn more about the code that I've been showing you, this is the project that we've been working on called Apollo, which is, you can check it out at apollodata.com. So you can download all those code samples that I was showing you in various platforms. So we have React, React Native, Angular, even native iOS code, if you guys are into that. All right, well, back to the slides. So, another important question is who's actually using this stuff? So I showed you GitHub. The answer is basically everyone is using it. You can go to graphql.org/users to see people who have bothered submitting their logos to the website. But like I said, it was invented at Facebook, GitHub, Pinterest, Intuit, they make TurboTax is using it. So, it was only released pretty much a year ago, so you can see that in that short time, it's pretty likely that whatever company you end up working at is going to be either interested in this technology or already using it. So I think that's pretty exciting. Another thing that happened recently was Meteor, which is a company that I work at, I guess, just a reminder. We ran the first ever GraphQL conference last year in October. So if you guys are interested in learning more in depth about what people are doing with it, you can check them out on the GraphQL Summit website. Again, they're speakers from various different companies. Okay, so we've talked a little bit about what GraphQL is for, what problems it solves. We've talked about how it makes your app more efficient, maybe easier to write a little bit. You don't have to read documentation. Who's using it? And the last part that's really, really exciting for me, my favorite thing as a developer is having really awesome tools. So secretly, one of my favorite languages is Java, because when you're using Java, I think there are other languages that have this too, but Java taught me this. you don't have to worry about stuff. All your code is basically checked for you, right? Have you guys used Java before? Is that a thing you still have to do in classes? Raise your hand if you've like written a Java program. Okay, awesome. Hopefully you guys don't hate it too much. I heard a lot of people don't like it. But one of the great things about it is if you just load up some object in your application and you type like dot to get auto-completion, you can see all the fields that are on there. And one of my favorite things about GraphQL is that it can give you that experience for the API as well. So this is the tool that I already showed you. It's kind of a tool that looks at your GraphQL API schema and gives you this great editor for queries, so that's pretty sweet. But what would be even more awesome is having that inside your application code. So you don't have to open a separate tool anymore to type your query. You can just open your editor that you're used to using and start typing some queries to access an API and get the documentation right in there. I think they're in the animation here. Oh, there's some linking. Okay, they're really gonna do stuff. So right now, the only plugin that this editor plugin exists for is IntelliJ, which also has WebStorm for web development. But we're working a lot to make it happen in Android Studio, Xcode, Atom, Sublime, like whatever text editor you might be using. So you can see basically you can browse the different types in your schema, the different fields that they have. So while you're writing your app, you don't have to like go to a different place to consult documentation, which is pretty awesome. And one thing that goes along with that is static typing. So you guys, I guess, you might have heard about the difference between kind of statically typed languages versus dynamically typed languages. So JavaScript, for example, by default doesn't have static typing, so you don't know what types of objects you're passing around. But if you're using a statically typed language, like TypeScript, which is kind of an addition on top of JavaScript, or maybe you're using Java or Swift, you can actually compile your GraphQL queries into those typed languages. So not only can you get the auto-completion in your editor, you can get it in the rest of your code as well. So when you've written that query to load the data, when you pass that into your React component, if you use a field that you didn't load, for example, you can get a compiler error. If you loaded an extra field but you didn't use it, you can get a compiler error. Basically, you can have all of your code validate itself to make sure you're loading exactly the data that you need, which is something that has been much harder to do in the past. Yeah, so I showed you guys this already. Basically, how easy it is to take that query and attach it to a UI component in your framework of choice. There's also browser-based dev tools in Chrome you can use to inspect how your data is being loaded. Basically, I guess the moral of this presentation is you should really check out GraphQL because it makes basically everything about developing an app that uses data like way better. So that's like the singular moral of the story. And another thing we're working on as a company at Meteor is tools that help you run GraphQL apps in production. So this is a screenshot of a tool that we shipped recently called Optics. And what this does is it's a GraphQL specific performance analysis tool. So for example, one of the questions you might ask if you're a backend developer, let's say you're that developer at GitHub who wrote that GitHub API. And you wrote the endpoint that returns 10,000 fields. How do you know what fields people are using? You don't. You can never remove a field from any API because somebody's going to get really mad at you. So then you have to start versioning it. Like every time you want to remove a field, you have to make it like version 2, version 3. But because in GraphQL you're required to ask specifically for every field that you want, you can build a tool that will actually tell you which fields are people using. So that's one of the things that our product does. And another thing is cool because GraphQL has this nested shape that lets you request multiple resources at once. One of the things you might want to know about is what parts of my query are taking the longest. So that's another thing you can find out by looking at how long each of those fields took to resolve. So as a client developer, before you would access an endpoint, and that would return you a giant blob of data. And you don't really have much control over that. But if you're using GraphQL, what you can do is you can look at your server and say, well, this particular field takes a really long time. I looked at the chart, and maybe I don't need that data right away. So you can just eliminate that from your query, and then you can have your UI load faster without having to make any changes to the server. And then you can go complain to your backend developer that like, this one thing took too long. And that's pretty much the story. So I would definitely make the claim that for at least one of you, you're going to go to an internship or your future job and you're going to be using this stuff. And I will be very excited for you because it's much better than not using it. And if you guys want to learn more, here's a list of various websites. GraphQL.org is the main website for GraphQL. Apollo is the name of the project at Meteor Development Group that we're working on to build a lot of tools for GraphQL, because we think it's going to be a big part of the future. So we have our website, and we have a blog. And then there's also, if what you want to do is just try out the technology for yourself really easily, there's this tutorial website that we didn't build, but some of our friends in the community did, called learnapollo.com. So if there's one thing you do after this talk, if this stuff is interesting to you, then you could go check out that website and just do one of those tutorials. It'll take like less than an hour. Lastly, we work on a lot of open source technology, JavaScript development tools, GraphQL, and we're looking for both open source contributors, if you guys are interested in getting to open source stuff, and we're looking for people to hire. There's always more work to be done than we have time for. So if you're interested in either of those things, or you just have a question, feel free to email me at sashko@meteor.com. And I guess one thing that's kind of cool is for the first time, we're having a contributor week, which is going to be a week where we spend extra time helping new open source contributors get started, and help people learn how to use GitHub and get the project started. So if you guys want to get into open source stuff, we would love to help you, and now is a good time to check it out. Cool. Well, that's my presentation. So thanks. Do you guys have any questions? Thoughts?
Why is it called GraphQL?
That's a good question. So my first impulse was to explain why I think it shouldn't be called GraphQL. Let me first explain why it is called GraphQL, I think. It's because the people that designed it thought of this schema. So, this is a description of a set of objects on the left, and they reference each other, right? So authors have posts, posts have authors. So they thought of that as a graph, where you have different types, and those types are basically nodes in a graph that refer to each other. And if you can think of a query as a set of paths through that graph that kind of project the data in the graph into a tree. So it's a bit misleading because the query itself is not a graph. Perhaps the data you're querying could be thought of as a graph. But the query is definitely more a tree than it is a graph. So you could call it TreeQL. Other misconceptions that come up with it are people compare it to SQL because it has the word QL in it. But it's not like SQL at all because it's not a query language for databases. So I think it's called GraphQL because of those things, but it could just as easily be called something else. Any other thoughts, questions? Cool. All right. Well, feel free to email me if you're interested in any things that I'm. So, thanks. Or if you need help with your project, you can also. Because I had office hours last night, but not really anyone came. Probably because it was raining. I know it's because it was raining and not because you didn't want to talk to me.